the next coming to the motion in a plane chapter. So I'll just read out the introduction part. Okay. The physical quantities like displacement, velocity, and acceleration discussed in the previous chapter, that is a motion in a straight line, have magnitude or size and direction. The direction of these physical quantities is shown by a positive sign if they are along positive x-axis. That is, when a body moves in a straight line along positive x-axis. On the other hand, the direction of these quantities is shown by a negative sign if they are along negative x-axis. Okay. So as you know that in the motion a straight line chapter, we have just gone through the about this displacement, velocity, and acceleration, right? So this displacement, velocity, and acceleration has both magnitude and direction, correct? So we said that if the body is moving along a straight line, that is when the body is moving along the positive x-axis, we have taken the sign convention as positive, right? Similarly, when the body is moving along the negative x-axis, we say that we have taken the it as with respect to the negative x-axis, that is negative we have taken, right? So similarly, that was regarding the one dimension, right? We said that if the body is moving along the positive axis, positive x-axis, we have taken that one as positive, the value. Okay. Similarly, if the body was moving in a negative x-axis, we have taken the value as negative, correct? So that was regarding the one dimensional case. So now coming to the two dimensional case. Okay. So how we are going to represent that? Okay, let us see how we are going to represent that. However, in two dimensional motion, there is motion in a plane, and three dimensional motion in a space, displacement, velocity, and acceleration have two or three components. Their directions are not represented by positive or negative sign. To represent directions of these physical quantities and magnitude of their components along specific direction, the concept of vector is introduced. Okay. So as you know that in the case of motion in a straight line, we were just concerned about one dimension, right? We were just talking about the one dimension in the motion in a straight line chapter. So now coming to the motion in a plane chapter, as you know that it is regarding the two dimension. Okay. Similarly, when we take a three dimension, there is a space. Okay, correct. So in that case, how we are going to represent the direction of a, whether it can be of displacement, velocity, and acceleration. Okay, how we are going to represent the positive and negative side. Okay, we cannot write simply positive and negative. Okay, then how is that we are going to represent that? So that representation is given by vector. Okay, there comes the concept called as vector. Okay, so let us see what do you mean by the scalars and vectors. Okay, as you know that scalars is nothing but the physical quantities which have only magnitude but no direction. Okay, that is called as the scalar. Similarly, coming to the vector, as you know that the physical quantities which has both magnitude and directions are called as vector, correct? So this is the difference between the scalars and vector. So we will start with the basic things, that is what is the difference between the scalars and vectors first. Let us see. Okay, so coming to the first thing, that is first difference, as you know that scalar quantities only represents magnitude. Okay, coming to the vector quantities, it represents both magnitude and direction. Coming to the second point, it says that scalar quantities change with change in magnitude only. Next, vector quantities change with the change in magnitude or with the change of both magnitude and direction. Okay, so this is clear, I think, right? So since the scalar quantity only specifies the magnitude, so if there is a change in magnitude, obviously the scalar quantities changes. Okay, coming to the vector quantity, since you know that it depends upon both magnitude and direction. Okay, any one of it is changed, the vector quantities changes. Okay, next, Scalar quantities with same units can be added or subtracted according to the ordinary rules of algebra. Okay, as you know that if I say that suppose let us say that you have if you are solving some numerical, okay, just I'll say that subtract 40 minutes minus 10 minutes. Okay, what is the answer you are going to get? You are going to say that it is 30 minutes, right? It is a simple algebra, correct? And the units are same there, both are in terms of minutes. 40 minutes minus 30 minutes, so you can simply add or subtract the scalar quantities which is having the same units. Okay, but coming to the vector quantities, it cannot be the same as in the case of scalar quantities. You cannot add or subtract because vector depends upon both the direction and magnitude. Okay, it is not only regarding the magnitude, okay, it depends upon the direction also. Okay, so hence the vector quantities cannot be added or subtracted algebraically compared to the scalar quantities. Next, the scalar quantities are represented by ordinary letters. Okay, whereas the vectors are represented by bold-faced letters having arrow over them. So as you know that you can see here, the vectors is always represented by the capital letter followed by a arrow mark above it. Okay, so arrow denotes the direction. Okay, so this is regarding the some of the basic difference between the scalars and vector. So particularly in the previous chapter we just studied about the some of the physical quantities which are which we are going to say that when we are talking about the one dimension. Okay, we talked about displacement, velocity and acceleration only regarding the one dimension, considering one dimension. In this chapter we are going to study the same physical quantities like displacement, velocity and acceleration considering in two dimension. Okay, so that is regarding the motion in a plane chapter. Okay, so how do you going to, how we are going to represent a vector? Okay, so here I'll just read out. Always, to represent a vector you need to know two things. The one is nothing but magnitude and the another one is direction, as you know that, right? So as you know that the magnitude of a vector is represented by the length of a straight line and the direction is represented by the arrow head at the end of the line. So as you know that in the given figure you can see there, okay, the arrow mark denotes the direction and we call that as the head. Okay, so next, the length of the line from here to here, okay, it represents the magnitude. Okay, and this edge A is called as, okay, edge A is called as tail, whereas end B is called as head. Okay, this is how we are going to represent the vector. Simply from the figure you can say that vector P is equal to AB. Okay, AB represents a vector. Okay, so this is regarding the simple representation of a vector. Okay, magnitude is nothing but the length of the line which is given in the figure represents the magnitude and the arrow mark denotes the direction of a vector. Okay, so hence the vector is always represented by the bold letter, okay, followed by the arrow mark about it. Okay, so in this case in the figure P represents vector, P represents the vector. Okay, do one thing, just go through this first page completely. In case if you have any doubts you can ask. Just read out for a few minutes the difference between scalars and vector. Just go through the introduction once, difference between scalar and vectors and representation of a vector. Go through for a while. ಡೋರ್ ಕ್ಲೋಸ್ ಮಾಡಿರಿ, ಅವ್ರು ಮಾತಾಡೋದೆಲ್ಲ ಕೇಳಿಸ್ತದೆ. Any doubt, students? Okay, fine. See you. Coming to the vector representation, as I said, the magnitude of vector, okay, the magnitude of a vector can be represented by the modulus. Okay, so see here in the previous case, that is in this figure, as you know that P represents a vector, right? So the magnitude of a vector can be simply written, the magnitude can be represented by modulus, okay, or it can be written as simply P. Okay, so this denotes the magnitude of a vector. Okay, so in the upcoming definitions we are going to make use of this. Okay, so the magnitude of a vector can be represented by modulus of a vector or simply P. Okay, so next, coming to the position and displacement vectors. Okay, so here let us see what is this position and displacement vectors. A vector drawn from the origin to the position of a particle at any instant is called position vector. Consider a particle P at a distance x from the origin O along the x-axis. The position vector of the particle vector OP is equal to vector x as in the figure. Okay, okay, fine. See you in this figure. Okay, in the figure 2a. Okay, as you can see here, you have the two axes. One is x-axis, so this is the x-axis and this is the y-axis. Okay, so let us say that the object or a particle is at P here, point P. Okay, so if you want to represent the position of a vector, what you are going to do is you are going to draw a line from the origin till the, I mean at the particle, from the from the origin to the particle where it is situated. So this represents the position vector. Okay, and vector r denotes the position vector there, but here in the explanation part it is a printing mistake. Okay, vector OP is nothing but equal to, it should be vector r. Okay, a small correction. Okay, so vector r denotes the position vector. Okay, even here it should be vector OP is equal to, it should be equal to vector r. Okay, just make a small correction. So this is how, this is what you mean by the position vector. Okay, so next, coming to the, in the figure B. Okay, let us go to the figure B. So what happens if the similarly, even in the figure B, you can see there we have two coordinate axes, x and y axis. Okay, now consider that the point P, I mean at point P the particle is situated. Okay, so what we are going to do is, similarly this represents the position vector. Okay, this represents the position vector from origin to the point P. Okay, so next, coming to the displacement vector. Okay, so displacement vector is what? The displacement vector of a moving particle in a given interval of time is a directed line segment from the initial to the final position of the particle. It is said that consider a particle moving from P to Q, P to Q in the time interval t in the xy plane. Then the displacement vector of the particle is given by vector PQ is equal to OQ minus OP. That is nothing but equal to vector R2 minus vector R1. Okay. So here in this case, to represent the displacement of a displacement vector. Okay. Let us say that now the particle is at P here. Okay. Let us say that it makes a displacement from, it moves from point P to point Q. Okay. So you are drawing a, suppose you are drawing a line from the origin from O to P, similarly from O to Q. Okay, and this line which you are drawing from P to Q represents the displacement vector. Okay, so both this line drawn from O to P and similarly from O to Q represents the position vector. Okay, both represents the position vector, and let us say that for some time interval, okay, the particle makes a, the particle moves from point P to point Q. Okay, and this vector, this line which you have drawn represents the displacement vector. PQ represents the displacement vector. So hence mathematically we are going to write vector PQ is equal to vector OQ minus vector OP. That is nothing but equal to vector R2 minus vector R1. Okay, so this is regarding the displacement vector. Okay, do one thing, just go through position and displacement vector once, read the definition, compare that with the figure, understand. Okay, go through for a few minutes. In case if you have any doubts, please let me know. Okay, Inchara, what doubt you have? Representation of a vector. What is there to represent the vector? It is simply represented by vector P. Okay, in the figure you can see there vector P denotes the vector. Okay, that is nothing but equal to AB. Okay, always the vector is represented by the magnitude and direction. Okay, so in the this figure you can see here, this length denotes the magnitude. Okay, length denotes the magnitude and arrow mark denotes the direction. That's all regarding the representation of the vector. Yes, any doubt regarding the position and displacement vectors? Okay, fine. Coming to the types of vectors. Okay, coming to the types of vectors. First one, you have equal vectors. Okay, when do you call the two vectors are equal? Okay, two vectors are said to be equal if both have equal magnitude and same direction. Okay, you can see the figure 3a here. Vector a and vector b has same magnitude and both are directed in the same direction. So hence this type of vectors are called equal vectors. So hence mathematically you can write vector a is equal to vector b. Okay, so the example has been given there. The displacement of the two boys running in the same direction and cover equal distances in equal interval of time, where the angle between two equal vectors is 0 degree. Okay, so as you know that the simple example what they have given is two boys running in the same direction covering equal distances. Okay, so direction remains the same and they are covering the equal distance, so hence that is an example for equal vectors. And in the case of these equal vectors, always the angle between the two vectors will be nothing but equal to 0 degree. Okay, so next, coming to negative vectors. When do you call the two vectors are negative? Two vectors of equal magnitude but drawn in opposite directions are said to be negative vectors as shown in figure. Okay, so as you know that two vectors of equal magnitude but moving in opposite directions. Okay, so mathematically you can write vector a is equal to minus of vector b. Okay, so figure 3b, figure 3b represents the negative vectors. As you can see, vector a has been directed towards the right, whereas the vector b is directed towards the left. Okay, simply you can write vector b is nothing but equal to minus of vector a, since the both are opposite in directions. Okay, so as you know that the example for this comes out to be the displacement of two boys running in opposite directions and cover equal distances in equal interval of time. Okay, so the same example what we had taken in the last, in the previous definition, that is the equal vectors. Only the thing is, two boys are running in opposite directions, covering the same distance in same interval of time. Okay, and always the angle between the two vectors in the case of negative vectors comes out to be 180 degree. 180 degree in terms of angle, pi in terms of radians. Okay, so two vectors, the angle between the negative vectors is always pi or 180 degree. Okay, so this is regarding the equal vectors and negative vectors. So next, it is regarding collinear vectors. When do you say the vectors are collinear? When all the vectors are moving in same direction. Okay, see, just I'll read out the definition. Vectors having equal or unequal magnitude but drawn in the same direction are called collinear vectors. Okay, so in this case we are not worried about the magnitude of the vectors. Okay, so we are only worried about the directions. Okay, so let the vector, some of the vector has the uh, different magnitudes. Okay, we have taken the four vectors here. Let us say that all the four vectors have different magnitude, but all the four vectors should be directed in a single direction. Okay, so this type of vectors are called as collinear vectors. Okay, example for that, it is given the displacement of two boys running one after the other in the same direction but may or may not cover equal distance in equal interval of time. Okay, it is said that, as you know that the two boys who are running one after the other, okay, one behind the other also in the same direction, so both may not cover, may cover or may not cover the equal distance. Okay, equal distance in equal interval of time, that is called as, that is an example for collinear vectors. Okay, In the case of collinear vector, all the vectors which is given should be directed in the same direction. Okay, we are not worried about the magnitude here in this case, and the angle between the two collinear vectors is always 0 degree since they are directed in the same direction. Okay, so next is co-initial vectors. Vectors having common initial point are called co-initial vectors. So the example for collinear vectors is given in the figure 3c. Similarly, co-initial vectors are represented in the figure 3d. Just you can see there. Co-initial means where all the different vectors start from the same point, same initial point. So that are called as co-initial vectors. Okay. So do one thing, just go through till fourth. First one is which one? It is equal. Next is negative. Next is collinear, and the next one is co-initial. Just go through these four types of vectors. Okay, so I'll just take attendance in that time. So in case if you have any doubts regarding this today's topic what we have discussed, you can ask. Okay, fine. Madhumita, check the spelling of doubt. Okay, fine. At this point I'll stop it at this point. Okay, so from fifth, that is coplanar vector, we will discuss in the next class. Okay. Okay, fine, students.